we have division of polynomials. We have positive coefficients, so if you want, you can do long division. But the easier way, I think, is first to check what we have in the first polynomial. Because we have like m squared minus n squared plus 2nk minus k squared, we have to divide by m minus n plus k. We have here n squared, k squared, and we have 2n, but first two terms are negative and the third is positive. First, what I will do, I will take negative sign from this three term. Why? Because I see here that we can use form for square of difference. When we have a minus b to second power, this is equal a squared minus 2ab plus b squared. And when I take negative sign from this three last terms, so m squared I will copy and I will factorize negative sign from m squared, so will be n squared, now will be negative 2nk and positive k squared. Negative sign I have before parentheses, so when I multiply every term in parentheses by negative sign, I will get the same what I have at the beginning, because negative and positive give me negative, negative and negative give me positive, negative and positive give me negative. So I still have the same in the numerator. I didn't change anything. I only factorize negative sign because now I see that I have this form in parentheses. Only a is equal n and b is equal k. So let me copy the numerator, m minus n plus k, so this is equal. First term we will copy, and like I said, in parentheses we have square of difference, exactly the same what we have here on the right side. In our example, a is equal n, so we have n minus k to second power over, we copy the numerator. And again, square, we have square and difference. So we have here difference of two perfect squares formula. Let me remind you of this form one more time. When we have x squared minus y squared, this is equal x minus y times x plus y. In our example, x is equal m and y is equal, whatever we have in parentheses, n minus k. So now we can rewrite our numerator to multiplication form. And when we have multiplication form, we can reduce. So the numerator we copy, and in numerator we will have what we have, x minus y. So in our case we have m minus, and because we have minus before these two terms, so I will write this in parentheses, n minus k, and everything I will put not in the parentheses but in brackets now, because I have inside parentheses, and times, and open brackets again, and we have x plus y, so will be m plus, and parentheses, n minus k, close brackets. I just substitute to this form x by m and y by n minus k. This is our x, this is our y. We have here difference of two perfect squares. That's why I can use this form. And rewrite our numerator to multiplication form. So this is equal. Now, when we have parentheses inside, first we have to go to parentheses and check what we can do, because we have different variables, so we cannot do anything inside parentheses, but we can take down parentheses, and because we have negative sign before parentheses, so we need to change sign every term in the parentheses to opposite. So let me write the brackets. We have m to copy minus, now will be, here's like positive n. So now will be negative n. Negative and negative give me positive k. This is our first brackets. One more time. Negative and positive. So will be negative. Negative and negative, so it's positive. It's like negative times positive. Negative. Negative times negative is positive. And the second brackets, because we have positive sign before parentheses, so we just take down the parentheses and copy whatever we have inside brackets. So parentheses. To denominator we just rewrite. And what we see now, that in the first bracket we have exactly what we have in denominator. So we can cancel out. This is 1 and 1. So we have m plus n minus k times 1 is still the same over 1. So this is equal m plus n minus k. This is my solution. So it's very good idea to memorize a few formulas.